It's a digital delay timer with a couple of buttons, a LED display, and an input and an output. 2 LEDs I see, and the rest some resistors, an IC, and capacitors. I'm going to try this with the strip of LEDs. The first time I'm going to use these, they feel, qualitatively speaking, alright. Put it in the middle side. And the positive side, of course. This seems to be different. This is a single input. Process with components and printers. Idea will be the same. First open it. Put those wires inside. I see those a little more. I'm going to get a black battery of 40.8. I release the first two. I have a 14 volt battery. I'm going to use 14 volts. Output capacity can control the load with 30 volts, 10 amp, or even 220 volts. I need 2 amps for the light, so that's okay. And I want 14 volts. I'm going to first try with 1.5 amps. Set and on. This is the stop button. Stop and start. This is settings. Oh. Why is the LED out? Okay, turn it off and let's find out how I can turn on those lights, because this is only a signal cable. It's gonna open and close one polarity, so I'm gonna have to have a load from this wire to this wire. And I need to have a positive in from to this to my LEDs. I don't know if I can just pull a cable from here to here. Let's try. I can put one with the. Normally this line was running on the next paper, just across. This is bridged from the positive to the positive. If I take the negative in here and take out the positive from the LEDs, I don't have a positive on the LEDs. So otherwise this would just short out. Let's just follow the drawing. Let's try it out. The 12 volts coming out from here is to power the board at 12 volts, and then I loop it to where the relay is opening and closing between these two, and then if it's open, it's go to the LEDs, and I have my negative loop back to the negative. So now I have one timer at 2 seconds, 2 seconds off, I can see it, and 5 seconds on. Now I can normally change this. Where I have 2 seconds on, let's say. No, 2 seconds off, 2 seconds on. This is the on state. This is the off state. I'm gonna set this at a little bit more. I think I can put that at 2 amp safely. It's actually drawing 2 amp. 2.5. It's actually taking 2.5. But normally I can push the K1, which is this button, for 2 seconds. And then I have mode P1 to P4. P1 is a trigger delay. This is just operating with the LCD off. If I press this for let's say 3 seconds, if I turn it on, off and on, it just starts on the on position. Now I'm going to turn it off in the off position and see if it starts in the off position. Probably it should, because the relay is closed, open. No, it starts again, so it's always starting on the on position. Now it has a 10-second on delay. What is it? 0.1 second off delay. That's funny. It's also funny. 0 on delay and 0.2 on delay. It doesn't even turn on, it's too fast. There's no difference between 0.1 and 0.2. Oh, there is. I'm gonna break it. Yep, it's working. And now I kinda wanted to use it on the 220 load to power my 220 volt heating bed for a 3D printer. But I think I need another device for that, because this is a timer delay module, and I don't really need a timer module. So I need this. It's a solid state relay. It just opens when a lower voltage and a lower current is saying to open. So I can put a 220 device onto this side to make my Arduino from the 3D printer over my 220. So I'm gonna figure this one out later in another video. I'm gonna test it. Yeah, that's the plan for now. The LED is getting warmer, but they are rolled up. These LEDs will be used in a later project, which you will see later on. I'm gonna shut down this video and figure out some other stuff. That's it. Bye.